Hello, everyone, and welcome to the Project Connected Home over IP webinar. We are going to go ahead and get started. So a few details about the webinar. A recording of the webinar and the slides will be made available on the Alliance website. We will have time for questions at the end of the webinar. If you have questions throughout the presentation, please enter your questions into the Q&A box. If we do not have time to get to your question, please reach out to us at help@zigbee.org. At this point, I would like to hand it over to Michelle Mandala-Freeman, the head of marketing at the Zigbee Alliance.
Thank you so much and welcome everyone. We are absolutely thrilled that you were able to take time out of your busy day to join this Alliance webinar on Project Connected Home over IP. In today's session, you'll be hearing from some of the people who have had a direct hand in the creation of this groundbreaking work, understanding a bit more about our why, the what of Project Connected Home over IP, and updates on where the work is today and how you can get involved. As Taryn mentioned a moment ago, we will have time at the end for Q&A. So again, please do enter your questions and I'll be fielding those questions with our team at the end of the session. And to that end, let's show today's speakers. Everyone will have an opportunity to quickly introduce themselves and say hello during the session, but I would be utterly remiss if I did not mention that this is truly a powerhouse team. Just look at the group here. Many of these people are founding members of Project CHIP, whose companies contributed their own foundational market-tested technologies for smart home to help accelerate the delivery of this effort. We have leaders from across the spectrum of Project CHIP teams, from our steering committee, our certification team, security, technology, and even our product and marketing teams. And as you can see, as you look at these attendees, we have representatives throughout the entire IoT value chain, from silicon providers to platforms, devices, and even services. So if you had any doubts at all about CHIP's broad support and momentum in the market, I am confident that this panel of leaders will leave you very certain of our intent. But we do have a lot to go through today. So I thought it would be good to start with the end in mind. And if we can go to the next slide, thank you. And if there were only a handful of things that you walk away with today from this session, it would be these. Firstly, the Alliance is the place where IoT is happening today. We have brought together an absolutely amazing group of companies to create a single IP-based smart home and smart building standard to help unify the Internet of Things, to make IoT products easier to develop and make them easier to use for consumers. Our design is thoughtful, it's secure, it's comprehensive, it's built on strong foundations, as I mentioned, it's resilient and flexible, and it's ready to carry us into the future. And I also want you to know that we are here and ready for you today. We absolutely welcome companies and developers to get involved now. And so maybe you're here on this call as a member of the Alliance, but you really haven't yet participated in Project CHIP. Maybe you're thinking about joining, or you're thinking about your next IoT product or technology investment. With test events underway now, and our certification program opening up at the end of this year, or later this year, I should say, now is the time to get engaged and be a part of the first wave of what comes next in the Internet of Things. So before we turn it over to our expert team, I wanted to just spend a moment talking to you a little bit about the Alliance. You might not know this, but we are nearing our 20-year mark as an industry organization. And throughout this time, we have been grounded in two very basic things. Firstly, in the belief that all objects can work together to transform our lives and to change the way we all live, work, and play. And the second is that we strongly believe and know that our role in creating this transformation is to be that catalyst for change. We are the place where collaboration happens. We're the place where our members can step away from their market positions and work together to create and involve global open standards, to promote those standards, and to ensure that we all have the tools and infrastructure in place to make those standards work and really come to life, from reference code to test tools to certification programs. And I'll tell you that this really isn't just talk. We have proof of our collective ability to create this kind of environment and to deliver results with, to, and for our membership. Firstly, with technologies like Zigbee, arguably one of the most successful and widely deployed IoT technologies. Also with our work in Common Data Model, which is foundational to IoT value creation. And now with Project Chip, the latest in our collective efforts to help transform and to grow and change the Internet of Things. And so now to talk a little bit more about Project Chip, let me hand it over to my colleague, Oren Siegel from Apple. Thank you.
Hi, everyone. I am Oren Siegel from the Project Connected Home over IP Steering Committee. The Project Connected Home over IP is a working group of leading smart home providers from around the world with the intent of developing an open and royalty-free connectivity standard for smart home devices. The project goal is to simplify the development for every manufacturer by using a single connectivity protocol among all devices. And this will enable everyone to enjoy the benefits of smart home worldwide. The project uses IP for networking, which is the most common network layer used in our homes. And this will allow using standard IP technologies for the future smart home. Project Chip application layer runs on top of Wi-Fi for high bandwidth application and Thread for low power and low bandwidth application. We have security and privacy as fundamental design tenets for the project. The specification and implementation are all built on top of existing proven technologies that are already in the market, and this will ensure reliable, easy, and security experience for customers. Connected Home over IP is an open source project. This will allow adopters to use this code and speed up their product development. The project's certification program will ensure interoperability of the various Connected Home over IP components. And with this, I'll move it to Assad to tell you more.
Thank you, Oren. And thank you, Michelle, as well, for a great introduction. So folks, I am Assad Haq. I work for Comcast, and I'm also the vice chair of the CHIP Steering Committee, Project CHIP Steering Committee. And I have had the pleasure to be involved with this project when it was just an idea in the summer of 2019, since the summer of 2019. So one of the key things that we are addressing with this project is to unify the IoT industry. Today, as we know, the IoT industry is fragmented with number of incompatible protocols, stacks, and specification. And we are hoping to change that by providing not only a world-class specification, but a fully implementable, open sourced, secure code that will be available for anybody to download and start being part of this great project. So why are we doing this, right? There are obviously many reasons, and you will hear from other speakers rest of the webinar. What I want to hit on is the unification. Why is that so important? Because without that, we can see the frustration at the hands of consumers, because when they buy an IoT device, they have to contend with, will it work with my favorite ecosystem? Will it work with my app? Will it work with my other already deployed device? We want to change that. We want to make it so that if you see a product that has the appropriate certification, you know it will work. The buying experience will be simplified, and from users' perspective, they will know that they're getting something that is compatible, secure, tested, and will work with the leading world brands. Similarly, developers today have to contend with many different specifications, protocols, algorithms, which leads to increased inefficiency in building and deploying IoT products. It also leads to additional time to market. But if we had a compatible standard that everybody adopted, that work across the platforms and all shapes and sizes of devices, I think it will make developers' life a lot easier as well. And it also means that the retailers will also benefit from this because they will not have to contend with multiple SKUs and what what product to showcase. It will all lead to a simplified buying experience as well from or selling experience from retailers' perspective. So with that in mind, what we are hoping to do is provide a simple, unified, compatible, and secure, delightful experience to our consumers, developers, and retailers. And to find out more how we are doing that, let me turn it over to Mark from Smart Things. Mark, all yours.
Thanks, Asad, and hi, everyone. I'm Mark from Samsung Smart Things. I also serve on the Zigbee board of directors. Let's take a quick look at the chip technology stack. One thing that's important to understand is the difference between a network protocol and an application layer. Network protocols like Wi-Fi and Thread let devices connect to each other. But to do anything useful over those connections, devices need to speak the same language. And that's the application layer. For example, even though many smart home devices use Wi-Fi today, they still need to implement different application layers for every ecosystem. Chip is a common application layer and a data model that delivers interoperability between devices, allowing them to communicate with each other, regardless of the underlying network protocol or ecosystem. And since chip is based on IP, it can run over multiple network protocols, including Wi-Fi and Thread, and it uses Bluetooth Low Energy to assist with device setup. Chip is secure, and it's being developed as an open source project, and we'll touch on both of those points a little bit later. And lastly, chip is optimized to run with a very low overhead, making it suitable for a wide range of device types. Now I'm going to turn it over to Anne from Tuya Smart, who's going to talk more about the types of devices that support chip.
Thanks, Mark. I'm Anne Olivo-Shaw, and I am the Marketing Director for North America for Tuya Smart, and I'm a member of the Marketing and Product subgroup within the CHIP Working Group. Project Connected Home over IP aims to support a wide range of smart home devices. The working group is first focusing on common consumer smart home devices, and a number of brands working on the effort have devices in these categories that are already in testing and development. As other device types, as well as other commercially focused device types will be supported over time. As an open standard and open source project, we expect this list to grow rapidly as companies from across the industry contribute and collaborate on new device types. There will likely be more news about specific products as we get closer to launch. As the technology stack comes into focus, so do the smart home devices that we are initially targeting, which include lighting and electrical, such as light bulbs, luminaires, controls, and plugs, window treatments, such as blinds and shades, HVAC controls like thermostats and AC units, TVs, access control like door locks and garage doors, and safety and security like sensors, detectors, and security systems. And some of these are part of the chip infrastructure like access points, bridges, and controllers that administer and control the network, which we'll get to in just a minute. Scoping exercises are also underway for additional consumer electronics products and the commercial industry. And it's important to note that just because you don't see a device type or category listed here, that doesn't mean it won't eventually be supported. As spec development progresses, we expect there to be a continual evolution of supported device types. There are already groups within the effort working on new device types as fast follows to this list. So if your brand's devices are on this list, then join the effort and get engaged to get your devices working with chip in 2021. And if you don't see your offerings here, there's still a good time to get involved and join the work so you can get your device types included in the next round ready for certification. And with that, I will pass the floor over to Daniel with Google to talk about chip network topology.
Thanks, Anne. So hey, everyone, I'm Daniel Mineta from Google, and I'm chair of the marketing subgroup here at CHIP. So you've now heard from Mark about how CHIP works relative to the technologies it integrates with, and from Anne about what kind of devices CHIP will support. So let's take a look at how all these pieces will come together, exploring an example of a chip-enabled network and the various ways devices can connect to each other using CHIP and its supported networks. Let's start with a chip controller, which, as it sounds and you just heard, is an entity that administers and controls other chip devices. Chip controllers can be built into many different types of products, whether embedded in a smart speaker, a security panel, a smart home hub or display, or mobile operating systems and apps. That controller might belong to a smart home ecosystem. It might be a single device vendor's app. Chip is really flexible, so it's enough to work for your first device or your 100th device. These devices typically connect to each other on a local network via Wi-Fi or maybe Ethernet. They may also have a cloud connection for their own purposes. For our initial release, Chip is really focused on local communication, but we're showing this cloud connection here for completeness, as it's obviously an important part of a lot of applications. Onboarding a new Chip device is easy. Chip uses Bluetooth Low Energy to make commissioning easier, whether you're using a smartphone, smart speaker, or another device to commission it. Speaking directly to that chip device via BLE allows the commissioner to onboard it onto your network. In this case, we're showing a Wi-Fi connection, and to provide any necessary chip credentials. The same process can be used, of course, to onboard any number of devices onto that Wi-Fi or Ethernet network. Now, of course, Chip also supports Thread as a network layer, and the same onboarding process works for these devices too. Thread devices will connect to users' networks through a Thread border router, just like your Wi-Fi router links your Wi-Fi devices to Ethernet. A Thread border router does the same, linking Thread devices to your network. Border routers can also be built into Wi-Fi routers, smart home hubs, or even other smart home devices, making it transparent for the user. But as Mark mentioned, because Chip works over all these IP networks, however devices are connected to your network, they can interact directly with each other using the same Chip application protocol. IP creates other advantages as well because it's the native network technology of the internet. So while Chip provides for robust, responsive local communication, devices can still connect back to their own clouds or other services if their applications require it. This is a pretty key benefit of IP as a foundational technology, as it allows users to connect their devices to any controller or ecosystem of their choice, but it still allows those devices to use cloud connections with their manufacturers to provide added value, support, analytics, and other features should users want to do so. Now, one question we get asked a lot is, of course, but what about devices that use other technologies? These might be some of the millions of devices already deployed into homes and businesses using technologies like Zigbee or others, or it might be devices still to come that use other technologies that are just well suited for their particular applications. Project Chip's goal is to reduce fragmentation in the smart home, and so leaving these devices out wouldn't help achieve that. So to help solve for this, one of the device types supported by Project Chip are bridges, which enable manufacturers to build chip-compliant bridges to other protocols and allows the chip network and devices to interact with devices using those other protocols. Here again, these bridges can be built into a number of devices like controllers and smart home hubs, making that as seamless as possible for users. It's important to note Chip has not defined any particular set of protocols for the non-chip side of the bridge. That makes it a really flexible option for many applications, regardless of what's on the other side of that bridge. That said, of course, we think that building a chip native device is a great choice for anyone developing a new smart home device. And one of the reasons for that is its strong security foundation. So with that, I'll pass it off to Steve Hanna of Infineon to talk more about security.
Hi, I'm Steve Hanna from Infineon Technologies. As the lead of the security marketing team, I'm going to talk to you about security and privacy today. In the past, IoT security and privacy has often been a headache for everyone concerned. End users worry about the security of their home and about their personal privacy. And then they often struggle with complicated security steps. Device makers worry about ending up on the evening news for all the wrong reasons. Project Connected Home over IP is designed to avoid that. By bringing together 180 companies with many years of IoT security expertise, we've designed our security to be comprehensive and strong while also being easy for device makers and end users alike. Let me give you an example. In that last section, Daniel told you about setting up a new connected home over IP device. When you bring a device into your home, the controller automatically adds that device to your home network. And that's one way that Project Connected Home over IP makes security easy. The end user doesn't have to enter their network password into the device. It's handled automatically. And Connected Home over IP automatically adds several additional layers of security on top of that. So we get top-notch security without the end user even knowing about it. With Connected Home over IP, users and device makers should never need to worry about security. Strong security is built in from the start and managed over time so that your home can be resilient and agile, stopping threats before they become headaches. Now I'd like to hand things off to Kevin Poe of Google, who will tell you about our open source implementation.
Thanks, Steve. Hi, everyone. I'm Kevin Poe from Google, and I'm here to tell you a bit about the open source project. One of CHIP's key differences from other standards development efforts is that we're actively building the reference implementation in parallel with the specification. You can find it on GitHub at the URL presented on the slide. A reference implementation supported by the CHIP workgroup has a number of key benefits. First, developers have a faster time to market with an available implementation of the spec. Second, it improves quality since the code can be tested against a number of use cases and transports with bugs caught quickly. Finally, it also improves security where the community has transparency to identify and commit patches. We're able to take this approach since this protocol is based on contributions of market-proven technologies from member companies. By iterating early in code and taking an implementation-first approach, we can focus on landing a spec that works in the real world. The repository already has over 3,000 commits and compiles on many build targets, such as ones that support Wi-Fi and thread BLE combo radios. Check out the repository and kick the tires with the code on your favorite target platform. And with that, I'll pass it over to Naveen Kumareddy and Anthony Skoko to share details on our certification program.
Thanks, Kevin. And hello, everyone. I'm Naveen, and I'm the chair of the certification subgroup.
Hello, and I'm Anthony Skoko, Vice Chair of the Certification Subworking Group. We'll be sharing a few details about the Project CHIP certification program. Over the past few months, with help from several volunteers from member companies, we have made significant progress towards launching a formal certification program in late 2021. As part of this effort, we are developing tools and test harnesses that will be easily accessible and free to use for all members. These tools have been designed with automation and testability in mind for ease of use and integration into members' testing processes. The ultimate goal is to make it easy for companies to get their products certified.
And one of the most important activities currently in progress within the certification subgroup is the test event series, which kicked off in March and continues to September. Through these events, the certification subgroup has been validating various facets of the program that includes the open source SDK, the device implementations, interop, tools, test cases, etc. Now, what's really exciting for us is that we have dozens of device makers and chipset vendors who are actively participating in these events. These early participant devices, upon successfully completing the test events, will likely be among the first to receive certification. So, as you have heard, this is a very exciting time for us at Project CHIP. And in looking at our timeline, you'll see here that we will have formal certification open later this year. But if you want to be part of the first group of CHIP certified devices and speed up your time to market, I would encourage you to join now and start working with us today. And with that, Michelle, why don't you tell folks how to get in touch?
Awesome. I absolutely will. And thank you, Naveen, and thank you to all of our panelists speakers for spending some time talking to this group today about where we are and what we are doing and why we are doing it with Project CHIP. Before we move into Q&A, I will just remind you that if you are interested in learning more or joining us, just reach out. You can either visit our Alliance website at zigbeealliance.org. You can take a look at our Project Chip site at connectedhomeip.com. And then if you want to just ask questions, learn more, get in touch, both of those sites have an opportunity for you to submit some information so that you can get in touch with Alliance personnel, or you can absolutely send us an email at help@zigbee.org. As a reminder, we are recording this, and we will make the recording and the presentation available on the Zigbee Alliance website, so you will have access to all of this information as well. And now I think it's time perhaps to move into a Q&A. So as our speakers have spoken, there has been a lot of questions coming in from the group. And I think I'll probably start with one that seems to be coming up an awful lot. I think one of the first folks who put in a question about product availability was Rob. So Daniel, why don't you tell us a little bit more? I think we may have covered some of this, but maybe you can tell us a little bit more about availability and timelines, and in particular, when the specification would be available.
Sure. So maybe I'll start with the latter. So we actually now have a full draft spec that's available to project members. One of the advantages of being a member of the organization is influence, but also access to the spec. And that's in the process of being ratified now. We're also hard at work at ensuring support for all the device types that we spoke to earlier in the webinar. And in fact, as Naveen mentioned, we are, and Anne mentioned, we already have groups working on defining the next device types and testing the current ones. The pace of this progress is unprecedented for a technology of this magnitude. And as you saw, we're expecting for the spec to be ratified and available publicly, and those first certified devices to be available in late 2021. You did hear Anne talk about the device types that are targeted to be supported at the launch of CHIP. We can't speak on behalf of individual members' companies' plans, but I would suggest paying attention to what those companies say publicly in the lead up to launch, or reach out and contact them yourself. I'm sure you'll hear from a lot of companies this year about what their plans are for CHIP. And you'll definitely be hearing more from us as an alliance as we continue to hit more milestones. It's important to note, however, that even once the spec is ratified, again, new device types can still be added. And as I said, we already have groups working on some of those new ones.
Excellent. Thank you so much, Daniel. Another set of questions that seem to be coming up in the Q&A had to do with the certification program and certification process. We talked a little bit about some of the efforts that you have underway, Naveen and Anthony, but maybe people would like to learn a little bit more about the how and what we can say today. And I think both Rachel and Ragnar were the first two people who put in questions for certification programs. So I'll give a shout out to them and ask you to answer that question.
Yes, good morning. So Rachel, your question about certification is, for a device based on thread and chip, do we need to certify it with chip and thread, both, or is it enough to only certify it with chip? So in Project Chip, we are building a certification program to certify against the chip specification. Now, for those devices running on thread, we are looking into the processes, but we would most likely anticipate that you would need to work with the Thread Alliance to get your product certified over thread too. So that's the answer. And there was a second question. Well, with certification devices be expensive. Now, as Anthony mentioned, the tools that we're building are going to be freely available to all members. So what our goal is to make the product development process as well as the testing process simple, so that when you go to labs, your product should be able to go through the cert process very quickly, which may translate to costs.
Thank you so much, Naveen, and appreciate your answers on certification. Couple of questions have come up around security and privacy, and Abaza had asked, and Steve, maybe you can handle this question. how are we addressing the issues of security and privacy and those points with customers?
Good. So let me go into a little more detail about our security and privacy architecture. Clearly, security is a top priority for consumers and IoT providers. In order to address this concern, Project CHIP has built-in defenses against a wide variety of different threats using a security architecture that's based on best practices such as security by design and zero trust. So to implement this architecture, we've designed in security measures such as every device tested and authenticated, every message protected, easy and secured user experience, solid, open, and standard cryptographic algorithms, and secured over-the-air updates. And with those put together, we can build a really secure and environment for our consumers.
Excellent. Thank you so much, Steve. Let's see, we had a question from Andre about memory requirements and memory footprints, and that kind of leads to maybe a more technical question about that. Kevin or Oren, could one of you please address this question about the memory requirement for Project CHIP?
Yeah, I'm happy to start, and then Oren, if you feel free to chime in. So I think the question was around memory requirements and what impact it'll have on their devices. I think with respect to memory requirements, there is a reference invitation, but as a standards development organization, it's an area that we can't comment on directly. It's not an answer the way we can answer directly. With respect to the design, feel free to kind of use the reference implementation, do some profiling. Also, there is, as Daniel mentioned, that specification evolved. By joining the Zigbee Alliance, you can actually kind of review it, and then if you choose to, you can actually implement that on your device as well too, and then profile that way. But Oren, if you have some additional thoughts, feel free to chime in.
Sure, thank you. I will just add that this is an open source project, so you guys can join the open source project and download it and see how it works. And yes, we do. The open source project developers are also focused in trying to make sure it supports also devices where memory requirements are low.
Thank you, guys. Absolutely. And a reminder, I know there were a few questions again about getting access to GitHub and looking at open source. When the presentation is published, you can go out and look for it today, but we'll have those links in there as well. So you'll be able to go in and as Kevin said, poke around, kick the tires, and experiment with our open source reference implementations. Anne, maybe I can ask you a question. I think there were some questions that had come in from the group a little bit about what role Zigbee plays here. Maybe kind of how does Project CHIP work with Zigbee? Would you care to answer that?
Yeah, sure. Thanks, Michelle. I think that there can be a lot of confusion about this, so let's try to make it really clear. We can talk about this from both a technology and from a user perspective. From a tech perspective, Project CHIP does utilize some of the same underlying technology that would be familiar to Zigbee developers. Project CHIP supports the same 802.15.4 radio technology as Zigbee, but uses thread and IP-based technology for the network stack. And at upper levels of the stack and spec, Project CHIP's data model borrows heavily from what those familiar with Zigbee know as the Zigbee cluster library. And while these are important elements in terms of ensuring that CHIP is based on market-proven and developer-friendly technologies, Project CHIP and Zigbee are different protocols. This will give product makers different options that are suited to their applications, but that also means that there's no native interoperability between CHIP and Zigbee devices. And as Daniel mentioned earlier in the webinar, our goal is really to unify the industry. And we needed to make sure that the Project CHIP ecosystem would be inclusive of products that chose Zigbee for their applications. And perhaps even more importantly, for the tens of millions of Zigbee devices already driving great experiences in the smart home and smart business sector. And that's why Project CHIP also includes specifications for bridging devices so that product makers and ecosystems who have Zigbee as part of their current or future portfolio can create seamless experiences for users across these networks. And another question that comes up is whether Zigbee, Wi-Fi, or other devices can be updated to support CHIP. And certainly if those devices support the same underlying technologies like 802.15.4 and Wi-Fi that CHIP supports, that's a possibility. But of course, much of that depends on the particular device and the manufacturer. For instance, whether the device has the available memory or compute power, and whether the manufacturer feels that doing so would be a benefit to the end user versus other ways of enabling those devices into the chip world. So I hope that helps to clear up some of the confusion around Zigbee and chip.
Yes, thank you so much, Anne. I appreciate that. Another question that had come up, and you mentioned it a little bit as you were talking about a smart home and smart building. We've had a few questions about other domains, and and I think it would be fair to mention, Daniel, if I may ask you to at least talk a little bit about that. This is the extensibility of Project Chip beyond smart home.
For sure. I mean, I guess the short answer of that is, you can use products in many different applications however you want, regardless of perhaps how they are marketed. The long answer is, as anyone in product management knows, you have to, when building something new, you have to pick, your core and foundational use cases. And many of those use cases across the industry are even core smart home use cases. It's also a market where you have the most number of potential growth in terms of users that aren't necessarily as technologically sophisticated as they may be in other markets and in more professional markets, and an increasing complexity and barriers to adoption and growth. So we really wanted to start with a smart home. That was really where a lot of the foundational problems needed to be solved. But that said, if you look at all the device types that Anne talked about, all of those have immediate applications in commercial. And in fact, despite the project being called Connected Home over IP, the Zigbee Alliance has a very strong, history and presence in the commercial space. And we have a large number of commercial members. For those of you that have been keeping an eye on our news, you probably saw a couple months ago that in fact, we've formed a commercial group to work on commercial and professional applications for chip. They have identified many different use cases where existing chip devices fit perfectly well into existing commercial applications. One of the reasons for that is because chip devices are based on IP, which is what almost every commercial IoT system is based on. So it's really easy to bring those in at the edge into commercial networks. And just as we have groups working on what some of those next device types are going to be, we have commercial groups working on, perhaps what some extensions to the spec might be in the near future that would help with, very sort of professional commercial use cases, things like commissioning that's different out of home and in offices versus smart home. So chip is certainly not exclusively targeted at the smart home, but we felt that by solving a lot of the problems in the smart home, that would be broadly applicable to all of the markets it could be used in.
Thank you so much, Daniel. And I'm so glad that you mentioned that. There is huge applicability and extensibility. And so, as we get this technology out there and embedded, we do expect to see that kind of spread. Mark, there are a few questions that have come up around other technologies, right? I've seen some questions in the chat about Wi-Fi, about PLC, about Ethernet, about cellular. So maybe you can comment a little bit about on our technology progression.
Yeah, that's a great question. There have been a lot of questions about, what's supported both initially as well as in the future. Initially, as I mentioned earlier, chip will be supported over Wi-Fi, Thread, and Ethernet. Bluetooth Low Energy will also be used for commissioning purposes. But within the Project Chip Working Group, we continue to evaluate other network protocols based on both member input and market input. And because chip is based on IP, it is suitable to run over many other protocols, IP-based networking protocols. So other technologies like cellular, broadband, or others may be in scope in the future. And those are all things that we're going to be looking at within the working group and all the companies that are participating with us. Great question. Thanks.
Excellent. Thank you. Thank you so much, Mark. Let's see. So we see some things in the chat. We also have some questions in the Q&A. I think, can we talk a little bit about some of the developer benefits and some of we've talked about open source, maybe a little bit more practical about like, what do we see in terms of developer benefits once people start? Kevin, would you mind talking a little bit about that?
Yeah, absolutely. So I think the question was around developer benefits, specifically with this protocol. And I think with Project Chip, one of the key benefits is ultimately there's one protocol, one stack that a device maker can implement to have wide availability and interoperability with a number of like major ecosystems that have committed and joined the overall effort. So with that, instead of having many kind of lightly differentiated SKUs to support like in the past, in the future it can have that one SKU, that one device can interoperate simultaneously with all these kind of different ecosystems and such, in addition to the experience that the device maker wants to offer as well. So that's a really key benefit around that. Ideally, that improves time to market for device makers, reduce costs, and allows them to focus on their user experience and help drive more value towards customers.
Excellent. Thank you so much. Let's see, a few other questions about hardware platforms, chipsets, things like that. Maybe Mark, we can go back to you for a quick answer there.
Yeah, if you look at the chip working group and the companies that are involved, you'll see many semiconductor and chipset platform companies involved and participating. There's a number of different networking protocols like we've talked about. And so there are going to be a lot of options available for companies and device manufacturers building products. We would encourage you to review that list of companies, and you can engage them and get visibility into what sort of reference implementations or development kits are available to start out with. But there's going to be broad support, and we expect many different options available. Thank you.
Thank you, Mark. Another quick question on security, Steve, if you don't mind, particularly around updating and firmware updates and things like that. Any kind of conversations happening in our security subgroup about this effort?
Absolutely. Firmware updates and software updates are part of connected home over IP. It's so important to have a way to update that firmware. People often say, well, I'm worried that this might become a backdoor, and you need to make sure that the firmware update capability is properly secured. And so we make sure that's there. But you can't just, install the firmware and leave it that way for years or decades, because things change. So yes, in recognition of that, we include firmware update in Project Connected Home over IP.
Awesome. Thank you. Thank you, Steve. Another couple of good questions I've seen before, and then one most recently about interaction with the cloud. Oren, can you talk a little bit about Project Chip and cloud compatibility, and maybe also between you and Daniel, a little bit about bridging?
Sure. That's a good question. So when we came together to work on Project Chip, we wanted initially to focus on the main problem of the smart home IoT devices, which is local connectivity. Because in order to achieve interoperability and good work between devices, you need first to solve locally how devices communicate, and doing it over thread and Wi-Fi. And on top of it, the application layer from Chip will help achieve this goal. Now, this is IP-based technology, so cloud connectivity can be achieved easily over IP in standard IP technologies. We understand that also solving the remote access with a standard way is a good goal to achieve. So we do have it in our roadmap to offer a solution for cloud connectivity. Thank you.
Thank you, Oren. Let's talk a little, there was a few questions about unification and things coming together. Assad, you talked a little bit about that at the beginning of the session. Maybe you want to talk more about that?
Yeah, sure. Thank you, Michelle. And as I was talking about, we had the choice. When we launched this project, we could have started 100% greenfield with developers coming and building, creating a spec and coding from scratch. That would have been inefficient and would have not led to unification as we are hoping. So instead, the 180 plus companies who have joined this project, they are contributing technologies, they are contributing specs that have already been tested in the market, that have wide adoption. For example, the data model and the interaction model is heavily borrowed from Zigbee with hundreds of millions of deployment in the world. So by bringing together technologies that have a solid footing and solid deployment and use cases, basically we are gluing all these interfaces together with the size and footprint in mind, obviously, and security in mind, to create a product that will provide the unification foundation for IoT devices. That's number one. Number two, this is also something unique that we will be doing. Where do you go to find out if device A is made by device manufacturer B and do it cryptographically? How can you get cryptographic assurance that this device is legit, authentic, and can pass the cryptographic tests involved? To solve that, we will also be providing a blockchain backend where these devices that are chip certified, anybody in the world will be able to go and ascertain the provenance of a device, so that you have high assurance when you're connecting a device to your home network. It has a lot of implications, and we want to provide the tools and means necessary to ascertain cryptographically, programmatically, that yes, this is a device that implements chip protocol, that has passed all the certification and tests, and you have high assurance and peace of mind when you're deploying this device on your home. Back to you, Michelle.
Excellent, thank you. And I'm so glad you mentioned the blockchain ledger piece too. I think that's a pretty pretty inventive and important component of our solution as well.
Yeah.
Let's see. So there were some questions, again, a little bit about kind of mesh networking over thread and device-to-device connectivity. Perhaps I can ask you, Daniel, to kind of mention again kind of how some of that network topology will work. Daniel?
Yeah, we're talking like general network connectivity or bridging specifically.
Yeah, so there was a general question about will this work over thread mesh networking?
I mean, chip is I've seen a lot of questions in the chat about application layer versus network layer. Going into stack diagrams would probably be an entire other webinar all on its own. But in general, a network layer is defines how bits move around. A network layer is like Wi-Fi or thread or Ethernet. It's kind of like how you and I having the same walkie-talkie and they can connect to each other. But as Mark said, just because you have the same network and you know how the bits move around, unless you're speaking the same language over those radios, you can't really do anything useful together. If you and I don't speak the same language over those walkie-talkies, we can't really communicate and do things useful. So that's what chip is. Chip is that common language that everybody speaks so that a light bulb and a light switch know how to talk to each other out of the box without those companies having to work together. Now, the advantage of chip is that it's not tied to one particular network transport. In fact, it's built on IP because IP is supported by a wide variety of network transports, and new ones continue to appear that support IP for a good reason, because it's the fundamental underlying technology of the internet. So for now, we've picked a couple that we think are really key to a lot of those smart home and commercial applications, which is, as Oren said, for Wi-Fi for sort of those high bandwidth, high power applications, thread for when you need sort of those long range mesh networking, low power applications. And of course, any of those features of those networks that are supported by those networks technologies I guess you could say would be supported by chip in that chip runs over top of them. So if you have a thread network that is doing meshing, which many of them do, then yes, chip will run over that mesh network. But that functionality is really taken care of by the underlying network layer, if that makes sense.
Yes, absolutely. Absolutely, it does. We have another question that is a little bit around more information about how the ecosystems will connect to chip certified devices. Perhaps Mark or maybe Kevin, would you care to comment on that question from a stack perspective?
Kevin, would you mind starting with that and I can add on?
Yeah, happy to start. So I think the question was how the major ecosystems were intending to integrate this the stack. I think with respect to the chip standard, it really specifies a protocol, like the protocol itself, and so it's really up to the ecosystems on how they want to integrate. And so I think going back to one of Daniel's original points, I think it's as the standard evolves and gets ready for release. Just stay tuned for those ecosystem companies to share what their plans are on how they want to integrate. I think ultimately, when going back to the fundamentals, right, we're all excited about the chip initiative because it really helps drive that interoperability and choice that users have been asking for and reducing purchase frustration. So I think we're all excited to integrate, and we'll find kind of unique ways, right, as individual companies on how we can deliver that value best for users. But yeah, it's just I think stay tuned for those individual companies to share whenever they're ready. But Mark, you feel free to chime in with any additional thoughts.
Yeah, that's pretty similar to my thoughts on it. So there's going to be a lot more to come in the coming months leading up to the chip launch.
Excellent. Thank you so much, guys. I think we probably have time for a couple more questions here. I know that we had mentioned a little bit about the Zigbee cluster library and data model. There are a lot of questions about the data model that Chip is using today. Maybe we can comment a little bit on the origins of that. And I think, if I'm not mistaken, Assad, you might have mentioned something about that already. Would you mind kind of clarifying the data model component of Project Chip?
Yeah, absolutely. As I said, it's built on the shoulders of giants. We didn't invent the contributing building blocks. When this project was conceived, put together, it was we needed to find a very mature data model that has a wide footprint in the market and has excellent extensibility and coverage. And with that, what was once known as ZCL and then was also and is also known as ... was adopted as the data model and interaction model that is at the top of the chip pyramid. If you look at the blue pyramid, that's often found on chip documents and on our public website, all the device definitions is based on the ... is borrowed from the ... data model. And the good news is that where we have gaps, companies are stepping up to define new devices, appliances, what have you, that are probably not in the library, but can be easily added. That's the extensibility piece that ... brings. Hopefully that answers the question, Michelle.
Yes, very much so. Thank you. I do still see a number of questions about backwards compatibility of devices or upgradability of devices. And do you want to maybe comment again on some of those concepts about how backward compatibility may work?
Yeah, sure thing. So again, it's really going to depend from brand to brand, manufacturer to manufacturer, and whether those devices are able to receive the upgrade. So the short answer is that yes, it's a possibility, but the longer answer is you'll need to look at the devices that you have already on the market and see whether they meet the requirements in order to meet that upgrade.
Excellent. Thank you, Anne. Assad, another one back to you. You got people excited about your blockchain insights, and people want to learn a little bit more. Can you take a little bit of a deeper dive into our blockchain implementation?
Yeah, we'll be offering chip coins pretty soon, so get ready for that. But but no, what we are doing in serious, what we are doing is providing a way for device manufacturers to create device footprints in a distributed ledger, which will be worldwide readable. Anybody in the world will be able to read uh, a product ID and a vendor ID that is printed on a IoT device, and check whether it exists in the IoT ledger, in the chip compliance ledger, as we call it. What that allows us to do is, manufacturers can update metadata about the device, about the OTA location, where you go to download the OTA, how soon the patches are available. All this information can be updated by the device manufacturers using their own key, and this information can be verified that it is coming from manufacturer A, and it's not made up or incorrect information. And the nature of this blockchain is such that anybody will be able to read it using public APIs and query different devices and their patch level, their OTA level, their operating instructions, and also determine if the device has passed certification. All of that will be, all these transactions are available in our blockchain that we are testing, and will be ready in time for the launch of chip devices.
Excellent. Thank you. No, thank you so much, Assad. I think we have maybe time for just two more questions. Mark, a question had come up quite a while back in the Q&A, a little bit about so many devices using 2.4 gig, concerns about interference, et cetera. Would you like to comment a little bit on that?
Yeah, sure. It's true. There are a lot of different protocols today using the same frequency bands, like 2.4 gigahertz. And because these technologies like Wi-Fi, Bluetooth, and Thread are broadly deployed today, there are a number of mechanisms already in place within these protocols to help reduce interference between them. Some of the mechanisms, for example, like dynamic channel selection or listening before they talk, different retry mechanisms, a lot of these are built into the actual network protocol stacks, which sit below chip. And so because chip is focused on the application layer and the data model, it sits above these different network protocols, and it can take advantage of all of these features that are built into the different network technologies. There are also a number of different system design best practices that manufacturers can use to reduce interference. These would be things like physically separating the antennas or implementing active coexistence schemes to share, to help control how they share the information.
Awesome, thank you. And here we are at the top of the hour, so let me wrap with just one final answer. Someone did ask a question about marketing around this and naming and being visible to consumers. I will just let you all know that yes, we will be launching campaigns relative to Project Chip in the coming weeks and months. We do aspire to work with our member companies to ensure that Project Chip compatible devices and certified devices are marked as such, so that consumers will be able to very easily see at the point of sale what devices will be compatible with this new and groundbreaking protocol. I want to thank you all again, all of you for attendees, for asking wonderful questions, lots of deeply technical questions. Unfortunately, we weren't able to get to all of them today, but we definitely will take note. Please do reach out to us if you want to learn more. Join the Alliance. We would love to have you here in Wave 1 at the foundation of this great new advancement in the Internet of Things. Thank you to our presenters today. We really appreciate you all for taking the time to talk to this community about Project Connected Home over IP. Everyone have a wonderful rest of your day.